Okay. All right. So we graphed it. We put our line in. 2x, negative 2x. I don't know where our line went. I don't know why it disappeared, but it goes down here. And then we checked our test point of 1, 3. It was right on the line, so it didn't work. Oh, that's why the big dot's on 0, 0. Yeah. So we checked it, and 0 was not greater than 10, so we shaded this side. And that's where we are right now, yeah? We. Okay. Please turn over onto 132 and notice something is different. What is different? There's no equal sign, right? So, we know that because it's an inequality, we have to split the Cartesian plane, yes? We know that that split is the boundary line, yes? And we know that that boundary line exists where this is equal, yes? So, the first thing is always the boundary. And the boundary is, of course, 10x minus 5y equals 0. So we solve it. Negative 5y equals negative 10x. Y equals 2x. Yes? Ease, bees, lemon squeezy, right? So we come over to our Cartesian plane. We set it up, and we put in negative 2x, or positive 2x, so 0. Now, you're going to need to use your brain here, right? When it equals, like the previous two examples, what does that mean for us if, for example, we put that point into the equation? That point was 1, 2, 3, 1, 2, 3, 4, 5, 6. 3, 6. In the previous examples, that point, 3, 6, what are we able to do with it? The same thing we do all the time. We see an ordered pair. What are we able to do with 3, 6? Substitute it back in. And is it true or not? In the previous examples, a point on the line, are they true or are they not true? They are true. Why? Why are the points on the line true in all of our previous examples? Henry? Yeah, because it's equal is allowed, right? So in all these previous examples, equal is okay. Is equal okay here? No. So is that line part of the solution? Yes or no? No, it's not. So the infinity of points that are on that line are not okay, are they? Is a point very close to it okay? Like, for example, is there a chance 2.99, 5.99 is okay? Yeah. But 3.6 is not okay, correct? Just like when we had one variable, 9, greater than 9, we can approach 9, but can we hit 9? So what do? We did an open dot, right? Now we can't do open dots, an infinity of open dots, can we? That would take forever. So what do you think we do in order to show that this line isn't really part of the solution? What is something we could do to that line? I haven't told you. I'm just wondering if in your imagination you could figure out a way that we could show that this line does not count. What could we do? Joseph? A dotted line. That is exactly what we do. So we have this line right here, and all we do is we make it dotted. So we go like this. Everybody cool? Now we've got our two solution regions. Only one of them is correct, but we have a problem, don't we? What is the problem with the usual test point that we choose? It's on the line, and we know that isn't one of the solutions, yes? So we have to choose a checkpoint where? Not on the line. But we would like it to be easy, yeah? What's the easiest way to do that? You could do 1, 1. I like to keep one of them as 0, personally. And then it just drops out, right? Like if I go to here, 0, 2, the x just disappears, right? And 2, 0. Sorry, my fault. Out here, 2, 0, the y disappears. What's 10 times 2? Is 20 greater than 0? So is this my solution side? So what do? Shade it in. Everybody cool? And that's it. So we got a new rule here. We remember. Boundary line points are only included when we have the equals to. If it's these, we still have to put the boundary line in because we still have to split the Cartesian plane up, right? We must split, we must split the grid, but use a dotted line. Or dashed line, whatever, broken line, whatever word you want. Broken line is probably a better word. That's probably what you would see in textbooks. Everybody cool? And we remember what that means, right? That means every point right up to this line. For example, this point right here, that is 2, 4, right? 2.001 4 would be okay. Everybody cool? But 2, 4 is not. Yeah? Okay. So you guys try this one. Go. I'll turn off the screen and I'll, of course, write it out. And then you can check and see if you did it right. Are we good? Before I turn the picture on, is the line steep or shallow? Shallow, right? Did we shade above or below the line? Above. Yeah? Everybody good? Boundary line was 1/4 x. Choose a test point. I chose 0, 5. Could you have chosen anything? Yes, but you couldn't have done 0, 0. Why not? Because the line goes through 0, 0, right? Everybody good? Okay. Now we're going to work the other way around. I don't know how well it came out on yours, but this is the shaded side. So if you need to, do that. I want to go the other way around. Okay? So I'm going to pause the recording. Test point 0, 2. So where does the 0 go? Where does the 2 go? The 0 goes for the x, the 2 goes for the y, right? So what we're going to get is 2, and then 2 times 0 plus 1, yes? Okay, so 2, what's 2 times 0? 0 plus 1, 1. Everyone agree? Which way do I run the arrow here? 2 is greater than 1. So, what is our inequality? Y is greater than 2x plus 1. Why is it greater than and not equal to? It's a dotted line. Easy peasy, right? No problemo. You do it. Go. Everybody should have gotten the boundary line, yes? Now this one is a real easy one to test. Why? 0, 0 is part of the solution, yes? So that means if 0, 0, however 0, 0 works, then we can use that, right? So I take my 0, 0, 0, negative 2, 0, minus 2, 0, negative 2. How does the arrow go? Zero is greater than negative 2. So y is greater than or equal to, why do I need it here? Because it's a solid line. Negative 2x minus 2. Yo. Because I went up 2 and ran negative 1. Now, ladies and gentlemen, if that happens, and it's going to happen in this unit, you forget something from grade 10 that I kind of gloss over like that, you got to ask me, right? Because I'm not in your heads. I do not remember. I do not know what you do or do not remember from Math 10. Okay? Everyone's cool? Okay, we got a real life sitch here. A word problem. This is what I was talking about at the beginning of yesterday, right? You've got yourself a situation. You've got to solve that situation. But there's more than one right answer, right? So you have a read of that. Talk to your neighbor as always. And see if you can figure out how can we deal with this? What are some things that the question gives us? Right. I got a max, don't I? Okay, so I got a max money of $50. Is that variable? No, that's not changing, is it? So it can't have an X or a Y, can it? What is changing? Right, I can buy glass or I can buy aluminum, right? Does it matter which is which? No, it doesn't, does it? So I can choose whichever one I want. What variables do we always like to use? X and Y, right? You're going to want to use X and Y. Could we use A and G? Yeah, whatever. And then we just decide which was X and which was Y, right? So I am going to say aluminum equals X and glass equals Y. Everyone agree? Whether you would write that or not, everybody sees what I've done, yes? Okay, now I need my boundary line, don't I? What is it? How do I write the line? We've done an example like this. We used the albums and the songs, right? What did we have to do? 60x because, well, glass is 60, aluminum is 175. Right, so 60, and we wouldn't usually write Y first, but that's cool, right? Let's, Priya says 60Y, because it's $60 for glass, and then what would the X be? 1.75X, yes? Everyone agrees? Okay, now let's make it an inequality that we can use. How would we write it? 1.75X plus 60Y less than or equal to 50. Everyone cool with that? What makes that barfy? There's a decimal. Right? 60. If I'm going to put this in slope-intercept form, what would I have to do? I'd have to move it all around, right? Well, let's start moving it around. We got to isolate Y, yeah? So let's isolate Y. 60Y equals, because we want our boundary, right? 60Y equals negative 1.75x plus 50, correct? What would you do now? We're isolating Y. We're just putting it in slope-intercept form, exactly like we've done 8 times. What would I do now? Thank you. Y equals negative 1.75 over 60x plus 50 over 60. Is that easy to graph? Why not? What's the slope? Oh, 1.75 over 60. Barf. Yes? Barf. Everyone agrees, right? What is wrong with this example I've drawn right here? Think about it. Why is this no good? What does this example show that we don't care about? Negatives. Why would I have any negatives? Can I buy a negative amount of aluminum? Can I buy a negative amount of glass? So I don't need any negatives, do I? So what makes this difficult? Well, 1, the equation is barfy. I'm actually writing barfy. I don't care. It's not really a math term, but I'm going to write it. What else is ugly? There's no negatives. We can only use the first quadrant. Yuck. Yuck, 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 right? So what can we do here? The equation's barfy. There's no negatives. We've set it up perfectly, right? All we need to do is shade now. And we already know where the shading's going to go, don't we? Right? Because let's be honest. We kind of know this, yeah? What's the y-intercept? 5/6, almost 1, yeah? And what's the slope? Is it super steep? or super shallow? Rise over run. Super shallow, yeah? So we know already that it's going to hit around 1 on the Y. Then it's going to drop, can only go to 0. Drop 1 and go out how far? You can go out like that, isn't it? Everyone agrees? Okay, but this is yucky to graph. Have we come across other things that are yucky to graph? What did we go to when we found something that was too yucky to graph? For example, a parabola that looked like this. What would we have done with that? Graphing calculator. So what are we going to do here? Graphing calculator. Do we need to? No. We could work it out. But we could also use our graphing calculator. So what can we do to find an answer? 1, paper and pencil. 2, graphing calculator. Now, I want to show you how to work this. You guys don't have a calculator in front of you because last time I gave you a calculator at the very beginning and it did not work out well for me because you were playing around in your calculator when you should have been looking at what I was doing. All right? So we're going to take a moment. I'm going to show you and then you're going to try. Okay? So I'm going to remind you that we are starting with 1.75x plus 60y or less than or equal to 50. That's where we're starting, yes? You don't need to write anything down right now. You just need to look. Everybody understands that, yes? Okay, I'm going to split my screen for a moment because I want you to be able to see the notes. Piss off. And the calculator. Oh, had you guys seen that yet?
No.
Oh, you hadn't?
No.
Oh, watch. Oops. Window. No, that's not what I need to do. Second format. Watch. What's that? It's me! Winking! Want to see the equations? Just for fun? All 10 of them. I have a lot of spare time when you guys write tests. Oh, that all recorded. Never mind. Kind of didn't want that, but whatever. Anyways, now I've got to clear it all off, though. Sorry, everyone. No, I have to. I need to use it. Oh, there goes my smile. There goes half of my nose. There goes the top half of my nose. There goes my winky eye. There goes the bottom half of my other eye. The bottom half of that eye. There goes some of my hair. Oh, it's just like real life. My hair's disappearing. Okay. What do you see there? Y equals. What do you see here? I see a whole bunch of poo, don't I? Everyone see? What do I have to do to that to make it so I can work with my calculator? Equal to 0? I got to isolate y, yeah? And we already knew that. And we've already done it, right? Y was less than or equal to negative 1.75 over 60x plus 50 over 60. Yeah? We already knew that, right? So that's our line, yeah? Okay, let's graph it. So I'm going to punch it in. Negative 1.75 divided by 60. Yeah? Oops, I forgot the brackets. Sorry. Bracket. Damn it. Negative bracket 1.75 divided by 60, close brackets, x, plus bracket 50 divided by 60. Everybody cool? Now, if you have your own calculator, I see some people playing along. That's fine. Graph. Oh, sorry. I had my grid off. Just let me change that so it's there. Now, what was wrong with that? That's not very easy to work with, is it? So I should change my window, yeah? What windows did I need? Or what don't I need? I don't need any negatives. So I'm going to go into my window. I'm going to make that minus 2 because I want that a little off the side. We remember that, right? So we have some room to work with. And I'm going to make my x max 100. And I'm going to make my x scale 10 because it doesn't matter. My y min, negative 2. My y max. My y max isn't very much, yeah? Because we know it's going to be really little. So I'm going to make it 2. Graph. Everybody cool? Everybody's okay, right? Now, oh, I forgot to take off the negatives. It doesn't matter. This is the only part I care about, right? So I am going to change that. I'm going to make my y max, my y min 0. Everybody cool? Easy peasy, yeah? That's mostly my first quadrant, right? I got a little tiny bit on the x just so we can see. Everyone is good, yeah? Okay. Now, I have a problem here, don't I? I've got my line, right? And I know I could put in 0, 0. And obviously 0 plus 0 is less than 50, right? Obviously, I know I would be shading it under here, yeah? Okay, now watch. See that right there, how it shows a line? If I arrow over to that, and I hit enter, look, it changes shapes. Thick line. What do you think that is? Shading, where? Would that be shading greater than or shading less than? It's up and to the right. Would that be greater than or less than? Greater than, right? What do I need? Less than, right? Because I got to be less than 50. Everybody agree? Now watch what happens. It shades it in for me. Everybody cool? Pretty easy peasy, yeah? I mean, we don't need it because we know it's under the line, right? We could still do it with pencils and paper, yeah? And all of you know how to do that because you would just do the slope and you just change the scale on the graph, like I did, right? So paper, pencil, graphing calculator, but on the graphing calculator we have to do a couple of things. A, you still have to isolate y. B, you have to set your shading. That is what? Yeah, less than y. That is when it is greater than or less than. That is the less than or equal to. And then this one is if it's greater than or equal to. And how do you set that? Arrow keys over to the left of y. Left of y equals. Is everybody cool? Everyone is good? Now, how do you work with that? Well, I would need a value, right? Because the question was, I can't even remember the question, we've been talking so long. The question says, find all the possible combinations. Right? So where do they all live? Under there, right? So, where was it? Who was it? Thank you, Sam. Sam gets a 5-star review for doing the underwear joke without being provoked. So, it's there, yeah? Everyone agree? Okay. So, what lives there? On X, I went all the way out to here, right? Everyone agrees? And on my graph, I went all the way out to here, yeah? So I can go out to that. What is that point right there? It's an x-intercept, yeah? How could I find the x-intercept to this? What do we do? How did we find x-intercepts? Second calc. And what were the choices? What do we want there? Intersect? 0. It's still a 0, right? It's an x-intercept, not an intersect. So 0. And we know how to do that, right? So once I get my y's close to 0, which I am, you can see right now, it's a pain on mine. There, positive, enter. So I could buy 28.57 of X, which was my aluminum, right? Any amount of aluminum from 0 to 28.57, I'm okay. But I need some glass, don't I? So I got to check my maximum up here. What is that? That's the y-intercept, right? Which is where the x equals 0. But we already know that from our line, right? What's our line? 5/6, yeah? So 5/6 of a square meter of glass would be the maximum amount of glass I could buy. So any amount of glass up to 5/6 of a meter, and any amount of aluminum up to 28. Everybody understand? So what do we call that? In math class, I'm all of these x's and I'm all of these y's. What do we call that? What do we call the group of x's in a function? Domain. What do we call the group of y's? Range. So inequalities deal with domain and range. Because an equality, we only have set choices, don't we? But an inequality, we have a group of numbers that could work. Like the records, right? I could buy 0, 1, 2, or 3 albums, my range, or I could buy 1 to 15 songs. And any combination between 0 and 15 and 0 and 3 worked. Everybody cool? Yeah? All right, do you think you're willing? You're not willing because it means doing work. You think you're ready to try on your own? Okay, so remember a couple of things. One, remember, y greater than, equal to, less than, equal to, greater than, or less than. Y has to be on the left for this programming to work. Right? And we remember that because 6, y is greater than 6, how would I shade that? If it was just one variable, let's say q. I don't want to confuse you with x and y. How do I shade that? On the right or the left of 6? On the right, because our letter is on the left, right? Q is greater than 6, so all the q's live out here, yeah? But if I change that order to 6 is greater than q, then where do I shade? Then I would shade on the left. I got to reverse it if the number's first. Everybody understand that? So if you work your equation out with the y on the right, then you got to remember that when you go into your calculator, you set this properly. Everybody cool? Yeah? Okay. If you want, go grab a calculator, or you can try and do it with pencil and paper. You try to do 133, and then once we've done that and gone over it, we'll fill in this key points to remember, and then you can try some work. Okay? Go. You don't need a calculator, remember, you can. Everyone agrees, right? Now, did everybody choose it this way? Of course not, right? So if you don't have X as tile and Y as stone, would you change it right now? Of course not, because it doesn't matter, right? So now, what else do I know? I got a max budget equals 150, yes? So how much is the tile? 250x. If I buy 1 meter tile, I'm paying 250, right? So 2.5x plus 6y has to be what? Less than or equal to what? 150. Right? Easy peasy lemon squeezy. And that is a really smart way to have set this up. Because of course you know you've got to divide by 6, right? And 150 divides by 6, doesn't it? So if you set it up that way, you're in good shape, yeah? So let's do that. 6y. Now I've changed it to equals because I need my what? My boundary line, right? Equals negative 2.5x plus 150. Y equals negative 2.5 over 6x plus 25, right? Easy peasy, yeah? And now we could graph that paper and pencil pretty easily, yeah? Where would it start? 25. And it would go down 2.5 and out 6, yeah? So how far down can I go from 25 to get to 0? No, how far down? How many 2.5 rises fit in 25? 10. So I'm dropping 10, so I must be running 10 times that, right? And I heard all of you say 60, yeah? So I'm out here at 60. Yeah? Everybody good? Solid line? Then what? Shade. Why am I shading down here? Because I have to be below 150, right? So what are all the possible combinations? Could I buy 25 kilos of stone? Now remember, let's be realistic here. I am building a mosaic. I need tile and stone. Could I buy 25 kilos of stone? But then I won't be able to make a mosaic, will I? So even though this is the maximum I can spend, the combination must be what? Can it equal 150 as a combination? but I just proved that it can't. If I buy 25 kilos of stone, how much money have I spent? $150. Do I have any money left for tile? So can I do the job? So is this okay? What does it really need to be? Less than. Because I have to buy some of both. So if I was doing this on a pencil and paper, what would this line have to be? Dotted. Now your calculator doesn't show that to you. You have to know that. Right? Henry. Oh, I see what you're saying. Yeah, so you could go in the middle. All right, let's talk about that. So Henry says, can I have something in the middle at, say, 30 for X? Right? I buy 30 feet of glass. Yeah? That's 30 times 2.5 is 660 and $75, yeah? That leaves me with some money for stone, right? So is that okay? Is it? You agree, right? So now we're back to thinking of this. Is that okay? So now we're back to here. So what does this say to you as a student? Is it enough to just write this out, or are there nuances to it in real life? Yes, this is true, but I can't have this as a point, can I? And I can't have this as a point, can I? So when I'm doing my domain and range, I have to be smart, don't I? Can I buy 0 of either of them? No, because then I can't make a mosaic, can I? So my tile, which was Y, 0, I can't buy 0. So how do I show this? What sign do I write here? Less than. I can't have equals. Tile. And what's the maximum tile I can have? I can't hit 25, can I? So I've got to be less than 25. So even though that's there, I have to understand in reality that my actual domain and range can't hit those, can they? And then what's my one for stone? Less than or equal to what? 60. Right? Are we good? Everybody's cool? If it works out nicely, paper and pencil, no problem. You'll be playing around with the calculators. Okay? 9:09, we got enough time. Key points to remember. What does a linear inequality describe? How is a linear inequality different from a linear equality? What does an inequality give us? Sorry? Right, it doesn't, yeah, okay. An inequality sets what? Boundaries. An inequality describes the, I'm going to hit my answer there. Describes the, and I don't want to use this word. Describes the, because the word is bad, because we use it in math, it means something else. Describes the possible combinations of variables that are greater or less than a boundary. How's that? Right? And what does it do? It splits the variables into how many regions? Right. Into 2 regions. All the points in one of those regions are what? I've split into two regions, which means all the points do something and the rest of the points don't. What do they do? Every point in one region is an X and a Y, yes? So what do half of them do that the other half do not? Say it loud, Joseph. They work. What do you mean by they work? How do you know they work? Right. All the points in one region satisfy, and the word you guys use there is work when subbed in. All the points in one region satisfy the inequality. All those points are what? What's the proper term we gave to the side where the answers live? If you need to flip back in your notes, flip back in your notes, because I'm going to be using these words throughout the whole unit. What do we call the region with all the answers? Right, that is the solution region. That's where all the answers live. Okay? The related linear equality. What does that give us? We can put it in slope-intercept form, but what does that give us? That gives us the boundary. The related equality, so y was less than x, is our inequality. But we need y equals x, the related equality. That gives us our boundary line to divide the grid into its two regions. We good? We good? The line is either. What are our options for the line? Dotted or broken, whatever you want to say. The line is either broken or solid. What makes it broken? That's how we're going to remember it, right? That's the step. The broken lines are greater than or less than are the broken lines. Why? Because the points on the line are what? Yes, the points on the line don't satisfy the inequality. And they're solid if the points do satisfy. Oh, nice typing. You must shade the solution region. How do I know where? Did I type it right on yours? No? How embarrassing. Proofread. Let this be a lesson to you, so you don't look like an idiot in front of people. Use Grammarly. Don't really. Just learn how to type. Spell check would have helped here too. But, huh? No. Although the way I speak, Grammarly should sponsor me because I speak grammatically correctly. I never dangle my prepositions, especially in front of teenagers. Did you hear? No, you wouldn't have, because you guys don't listen to the radio, because you don't. Some woman from Florida, and you know it's a good story because everything that happens in Florida is, she left Florida. And this is proof that we should, if Donald Trump really wants to build a wall, he should build it on the Florida, Georgia, Alabama border to keep Floridians in Florida, where they belong. They should not be allowed out. She was driving through Louisiana and stopped in at a roadside petting zoo. Now, only in America could something as asinine as a roadside petting zoo exist. So she drove into the roadside petting zoo and they had a camel. How many of you know what camels do if they don't like you? They spit on you. The camel spit on the Floridian woman. The Floridian woman took exception to said spitting, climbed over the fence, walked up to this 700-pound animal, and bit him. Guess where? On his testicle. Yes. Now there's a joke here beyond the fact that this Floridian woman did this. Some of you may know that bull testicles are eaten. They are called prairie oysters. So, of course, if you're going to bite a camel testicle, it must be a desert oyster. Florida. Just saying. Want to build a wall? I'll gladly chip in to keep Floridians in Florida. But it turns out, I found this out, it turns out the reason we hear so many stupid things in Florida is because Florida has different laws about what you're allowed to print in the newspaper. Yes. So if you do something stupid in Florida, it's easier for newspapers to print it. And then the rest of the world uses the internet to find idiotic headlines. And of course, there's more in Florida because they have different laws about what they're allowed to put in print. So it's really not, screw it, it is. Florida's a mess. Anyways, back to here. How do I know where to shade the region? What do I do? Test point. Use a test point. Use a test point. If it works, what do I do? Inequality. I shade over it. If it doesn't work, where do I shade? If it doesn't work, I shade the other side. Because, of course, if it works, that point is in the solution region, which means every point on that side is in the solution region. Is everybody cool? All right. Your work, you will notice I have circled stuff to do. You will notice I have circled nothing on page 135. Yeah? You should be able to see the shading there. 135 is sort of the, if you want the A, do some stuff from 135. You've got all the answers right there. Everybody good? Sorry, I used up like 5 minutes of your work time with the story about Florida.